flip-flop circuits. Flip-flop circuits are kind of the switching circuit. They are the alternatively making the switching and then making the conduction. So flip-flop is stable in either one or the two states. Suppose that the flip-flop is in the state or the state. The flip-flop will remain in the state forever unless something happens to change. That something could be removed or the supply voltage, or there could be the triggering of the flip-flop to the reset. So this is the way how flip-flops state can be changed. So in this case, the flip-flops are that we are alternately switching. So the switching state will remain going on unless you do something. So you do something means that you have to remove the supply or that you have to provide the triggering signal or the reset signal, and then its operation can be changed. So in this case, the flip-flop can be the NOR SR flip-flop or NAND RS flip-flop, NOR flip-flop, and a NAND flip-flop. So those are the NOR gate, NAND gate are utilized to design the flip-flop. So the inner diagrams you see the input and the output, and the outputs are diagram. So the input state and the output state, their relationship diagrams are included in the table. So this is the function of the flip-flop. We can design the flip-flop by using the NOR gate or NAND gate. So the flip-flops we are producing the waveform, so the fast waveform, and unless you change the reset, it will go on at the current state. The flip-flops are about let's into a clock they see there, clock out to the left you now pass go top in the clock they pit it. Now conduction on the left below pass it top in it. Now two low sound mugo. Now the cuckoo piano machine, Eddie a chain that is below sound in it. Piano musura balance with supply will pay for your medomo, trigger signal pay Biame. I look trigger signal pay like about the resell of the local. I will resell of the cabas to do a low sound what Piawame. And a Poma Chile the cabas with flip-flop as knocking it, look at the eyes flip-flop sheet, now negative look at the eyes flip-flop sheet. And a flip-flop the Balambo in it, to do a low there, true table bodio, Pobia Hardy. And a true table the other flip-flop a low loss of true table the pit, to do, yes, Saviamu was a to do, let's see, they were section in it, and the cuckoo Pialamu Pulo Madali, 2 years Saviamu was with the charge in Piawa today. So flip-flops are providing the clock and the timing circuit. So they are making that they are producing a pass and they are producing a pass and they are making the timing circuit. So the clock pass is updated by adding the NAND gate 3 and 4. So in this case, you can see that the IS flip-flop. IS flip-flop we can also see there's a clock pass. So the IS flip-flop is you see the first one is the cross connection flip-flop, and then we can connect the additional NAND gates 3 and 4. So by producing the NAND gate 3 and 4, you get the clock. So that we provide the clock and the flip-flop maybe the conduction, and then set and reset function. So when you put the set function, and so the flip-flop we start to operate, and then by providing the clock function flip-flop we make the conduction alternatively, and then if you want to store it, you have to provide the reset function. So this is the way clock and the timing circuits are provided by the flip-flop. Who said your Pobia Maro clock and timing circuit today? Flip-flop is a Boma Piola and a cross set of where I had a negative who in a flip-flop today. And our ma no do it 3 and 4 negative who tap your bounty like the bounty GRD, clock and timing circuit go below yard. And second clock like the flip-flop sabi low there, and be like the clock or moody view of flip-flop, Savian needed, and also timing look the local, and 80 Savian move yet does it here, no? The reset function will be about today. Then you can also see the operation of the clocks as a flip-flop. In the true diagram, you see the R input and S input. When you provide the R0 and S0, so Q is an output is unchanged. And then when you put the R0 and S1, then Q will be the high or the 1. And when you put the R1 and the S0, so that Q will be the low or 0. And R1, S1, you provide that with the intermediate state. So that this is the truth table, and also you see the logic diagram. Logic diagram, you see the S, Q, R, Q dash. So Q is a 1, in this case Q1 will be 0. And then we can provided CP with the cloud bus signal. So cloud bus signal has to be provided, and then depending on the IS magnitude, Juba will be provided as an output. So in this case, in the diagram, truth table is the provided above, and then the logic diagram is a bottom diagram. Who for RS flip-flopရဲ့ operation diagram ဖြစ်တယ်အဲ့တော့ပုံမှန်ဆိုရင် truth table ကိုပြထားတယ် truth table မှာဆိုရင် R supply က0 S က supply 0ဖြစ်တယ်ဆိုရင်Q output တန်ဖိုးဒီမပြောင်းလဲဖို့မရှိဘူးမူလရှိတဲ့အခြေအနေပိုင်းဆက်ရှိနေမယ်ဒါလို့ R 0တဲ့ S က1ဆိုရင် Q ဒီ high သို့မဟုတ်1ဖြစ်တယ် R 1နဲ့ S က0ဆိုရင် Q ဒီ low သို့မဟုတ်0ဖြစ်တယ်တကယ်လို့ R 1နဲ့ S က1ဆိုရင်တော့အဲ့ဒါဆိုရင် intermediate state ဖြစ်တယ်အဲ့ဒါကဘာလဲဆိုရင် truth table ဖြစ်တယ် logic diagram ကိုတော့ပုံမှန်ဖော်ပြထားတယ်logic diagram ပုံမှန်ဆိုရင် S Q R Q bar နောက်ပြီး CB ဆိုတာပါလဲဆိုရင် cloud path ကပေးရမယ် terminal ဖြစ်တယ် The next diagrams are D flip-flop and the T flip-flop. So D flip-flop diagram is we provided. It includes 4 NAND gates and then 1 NOR gate. And also there is the logic diagram and also the truth table also provided. So the operation of D flip-flop, data applied directly to the set input. So that we have to provide the set data to the set input, then the flip-flop will operate. And the next one will be the T flip-flop. The T flip-flop connection diagram and then also the logic diagram is provided. So this is the ways we make the wire up, the wiring the appropriate alternative wiring diagram. So by this way we can produce the D flip-flop and the T flip-flop. Now who set your problem about D flip-flop and T flip-flop ဖြစ်တယ်အဲ့တော့ပုံမှန်ဆိုရင် D flip-flop ကိုပြထားတယ်အဲ့တော့ NAND gate 4ခုပါတယ်နောက်ပြီးတော့ NOR gate 1ခုပါတယ်နော်အဲ့တော့သူရဲ့operation ကတော့ဘာပေါ်မူတည်လဲဆိုရင်အဲ့ဒီ data ကိုနော် set input ကိုတိုက်ရိုက်ပေးရမယ်ပေးတဲ့အခါမှာဆိုရင် D flip-flop အလုပ်လုပ်ဆောင်နေတယ်ဒါ D flip-flop ရဲ့ logic diagram နဲ့ truth table ကိုလည်းဖော်ပြထားတယ်နောက်တစ်ခုကတော့ T flip-flop နော် T flip-flop ရဲ့ပုံကိုလည်းပုံမှာဆွဲပြထားတယ်ပြီးတော့သူ့ရဲ့ logic diagram ကိုဖော်ပြထားတယ်Next one will be the master slave flip-flop. So the disadvantage of flip-flop is the flip-flop is supposed to work on the leading edge of the clock. When you provide the clock, so flip-flop should operate on the leading edge of the clock. But if you don't provide at least a differentiation circuit, so the flip-flop will also provide on the duration of the path. So that we have to provide a master. Master function is in the diagram. You provide the master function flip-flop, and then cascade with the slave flip-flop. Master function is it only provide the leading edge. So it only provide the leading edge to the slave function, and then the slave flip-flop will operate based on the commands from the commands provided by the master function. So this is the way we provide the master slave flip-flop. So in the truth diagram, you can see there's a truth table. So SR are the input, Q is the output. So that when the S0 R0, Q will be unchanged, and when the S1 R0, so there will be Q1, S0 R1, so also the Q also 0. And also the S1 R1 is not determined. So this today will not be provided. Only the S0 R0 or the S1 R0 S0 R1 that you will be operated. So this is the function of the master slave flip-flop. Master slave flip-flop function is it can provide the triggering signal, command signal to the slave flip-flop on the edge of the leading edge. On the leading edge, the master function provide the leading edge command to the slave flip-flop, and then slave flip-flop and the slave flip-flop will work on. So this is the master flip-flop operations principle. Who said before master slave flip-flop ဖြစ်တယ် flip-flop ဆိုရင်တော့သူကပေးလိုက်တဲ့ path ရဲ့ leading edge မှာသူကအလုပ်လုပ်ရမယ်အဲ့တော့ဒါပေမဲ့လို့ဘလို့ disadvantage ဖြစ်နေတယ်လဲဆိုတော့အဲ့ဒီ path ရဲ့အလဲဒါလည်းဒီ flip-flop အလုပ်လုပ်ရှင်လုပ်တယ်အဲ့လိုအဲ့ဒါကိုတော့ကာဝယ်ဖို့အတွက်က master function ကိုထပ်ပြီးထည့်ပေးရမယ်အဲ့တော့ master function ဒီ leading edge ကိုပဲ slave flip-flop ကိုပေးနေတယ်အဲ့တော့ပုံမှန်ဆိုရင် master function နဲ့ slave function နဲ့နှစ်ခုကို cascade လုပ်ထားတာတွေ့တယ်အဲ့တော့ master function ဒီက command ပေးတယ်အဲ့ command ပေါ်မူတည်ပြီးတော့ slave flip-flop အလုပ်လုပ်တယ်အဲ့တော့ပုံမှန်ထပ်ပြီးဖော်ပြတာ truth table ဖြစ်နေတယ်truth table ဆိုရင် S နဲ့ R ဆိုရင် input တွေရှိနေတယ် Q R ဆိုရင် output ဖြစ်နေတယ်အဲ့တော့ S0 နဲ့ R0 လို့ဆိုရင်က Q တန်ဖိုးကြီးမပြောင်းလဲဘူး S1 နဲ့ Q0 ဆိုရင်က Q တန်ဖိုးကြီး1ဖြစ်တယ် S0 နဲ့ R1 ဆိုရင်တော့ Q တန်ဖိုးကြီး0ဖြစ်တယ်နောက်တစ်ခါ S နဲ့ R တန်ဖိုးကြီး1ဖြစ်နေတော့ Q တန်ဖိုးကြီးမပြောင်းလဲဘူးအဲ့ဒါပါလဲဆိုရင် master flip flop ရဲ့ operation စာ function ဖြစ်တယ်with the JK flip-flop. So JK flip-flop function is similar to the master state flip-flop, but the only difference is that the output of the JK flip-flops are connected to input to obtain the trigger operation. So this means that to trigger this next operation, so this way this is where the cells are triggering, so the output function connected back to the input, then it will provide us self-triggering operation. So the connection diagram it includes the engage, also the NOT gate. They are provided in the diagram, and the next one will be the truth table. So the JK and the Q, JK are input and the Q is the output. When the J0 K0 value is remain the same, J0 K1 so output Q will be the 0 or the reset function, J1 and the K0 so Q will be the 1 or set function. And then when you provide the J1 and K1, that times the state will be changing. So this is the operation function of the JK flip-flop. Now to forget about so in JK flip-flop function today, JK flip-flop so in master state flip-flop to do to so in JK flip-flop output function output input set target. Set target target the operation function yasin sinai. And so in JK flip-flop engage bale, not gate bale. Now out major by two table, popular, a J net input net, you are output pit. J-Damo 0 net, Judamo 0 sweet, J-Damo 0 net, K-Damo 0 sweet, Judamoa, now Mula dimension, J-Damo 0 net, K-Damo 1 swing, Judamo the 0 the whole reset, J-Damo 1 and Judamo 0 so no. J-Damo 1 and K-Damo 0 so that Judamo the 1, the most step machine, J-Damo 1 and K-Damo 1 so no, Judamoa. US state gas with Piao Wari. And our JK flip-flop operation the diagram through the website. Then we talk about the encoder and the decoder. Most of the function signals are analog function. For example, motion of the shaft, on the temperature, pressure, they are analog function. So those analog functions are converted to the digital function. So we have to utilize the analog to the digital converter or AD converter. So that those analog to the digital converters we call the encoder. And in the meantime, the computer produces waveform in the digital format. Those waveform we have to interface to the real operation devices. In this case, we have to convert it back to the analog function. So the digital to analog converter or DA converter, we also call it decoder. So encoder and decoder are utilized to convert the analog to digital or the digital to analog. So that in the diagram we can see the analog to the digital converter. So that there will be the three IC and we have to provide the analog input and also the inverting input and non-inverting input. So by connecting this circuit, input will be the analog, but the output will be the digital waveform will be coming out. So those are the encoder and the decoder are principally. Now, problem encoder and decoder change. Now, now modern level the flow now approaching the temperature, approaching the pressure, PR, area with the analog function. The analog function will computer they digital function. Analog and digital so AD converter locally, the more encoder locally. Now, digital computer they top like this waveform it not driving signal they top like it. Any signal not digital format. Any digital format go. The get set is the mobile analog analog Piambo Jado Pao lower less way, DA converter load, to move the decoder load. Now encoder and decoder so analog and digital analog Piam with the reality. Now Poma Jalo Pia less way, analog digital converter, Yara and IC, but we be now got input beta, now inviting input beta. Every second you must input analog function, output digital format. Then in the diagram we can see the encoding matrix. Encoding matrix is this is for the input with the analog, but then we have to utilize the output with the digital. So we choose the gate connection. So AND gate connection, NOT gate connection, or the stroke connection, JK flip-flop connection. So that will be the input will be the encoding matrix. It will include the NOT gate as well as the NAND gate, and also OR gate, NOR gate, and the output will be the J gate flip-flop. So providing that those are two circuit components, we can provide this analog to the digital conversion. So and this is the encoding matrix. And so that this encoding matrix is with the binary coded disk. So binary coded disk will be the input with the constant, but depending on the disk rotation, output waveform will be the digital waveform. So those encoding matrix disk is utilized to convert the analog input to digital output. နောက်တစ်ခုဖော်ပြထားတာပါလေဆိုရင် encoding matrix ဖြစ်နေတယ် encoding matrix ဆိုတာပုံမှာဖော်ပြထားတဲ့အတိုင်းပဲ NOR gate တွေပါတယ်နောက်တစ်ခါဆိုရင် AND gate တွေပါတယ်နောက်ပြီးတော့ OR gate တွေပါတယ် NOR gate တွေပါတယ်နောက်အဲ့ဒီပါဆိုတာဒီ circuit အဲ့ဒီ circuit တွေကဘာနဲ့ထပ်ပေါင်းထားလို့ဆို GK flip-flop နဲ့ထပ်ပြီးတော့ပေါင်းထားတယ်အဲ့လိုပေါင်းပြင်းအပြင် input ဒီ analog function ဖြစ်ပြီးတော့ output ဒီ digital function ဖြစ်နေတယ်အဲ့တော့အဲ့ analog ကနေပြီးတော့ digital ကိုပြောင်းလဲတဲ့အခါမှာဆိုရင် encoding binary coded disk ကိုအသုံးပြုတယ် binary coded disk ကဆိုရင် input ကတော့ analog function ဖြစ်နေတယ်အဲ့ဒီ disk ကလဲပတ်ပြီးတော့ထွက်လာတဲ့ output ဒီ digital format နဲ့ binary coded digital format နဲ့ထွက်လာတာဖြစ်တယ် the digital to analog conversion. After you got this digital function, we have to convert it back to the analog function. So in this case, digital function is a pass 1001 no pass, and then we have to convert it to the appropriate voltage, so magnitude to the analog function. So we have to utilize the binary comparator. We use the binary comparator, then we convert the digital function to analog function. So in the diagram, we see the binary comparator connection. So that will be the binary comparator is provided. So two binaries are one and generate the logic one output if the two watts are equal. This way, when the two watts, in this case, I made the shaded watt. When the two shaded watts are equal, then output will be the logic one output. So this is the ways made the comparison and the output will be the coming out. So that those comparisons are provided by the NAND gate and all NAND gate outputs are provided in the AND gate. So therefore, all the input functions are digital functions. They are combined and the outputs are analog voltage will be analog signal will be produced from the device. So this is the binary comparator circuit. Now for digital and analog digital beta waveform 1001 so the waveform is generated also analog download binary comparator don't use it. Binary comparator shape shape Nakuma she there when I let the Tamona who are 2 meters away output Damodi, the logic 1 or 12. I 12 output logic Damodi a Kong Longoma, no Engama Su Palmio, no Su out now so output, no second Damo, Toby, Tajamlo, input the digital pit, Dore, 12 and also output and all function and 12 today. The next one will be the servo mechanism. So servo mechanism will be that we have to make the appropriate feedback function. When the shaft is rotating, so this shaft operation and the reference functions are made a comparison and we have to control back. So this is the servo mechanism. So in the diagram we can see the servo mechanism. DC motor is connected to the drain and DC motor is also coupled with the tachometer. So that tachometer shaft output voltage is proportional to the motor's rotation. So this tachometer shaft output voltage and also the combined with the reference signal and we provide it to the control signal, pass it through the DC amplifier. This is the way we can drive the DC motor. So this is the velocity servo mechanism. Now to what servo mechanism? Servo mechanism DC motor, DC motor, shaka nebio, no drea nebio, power DC motor, shakoma, tachometer. Capello Tare. Shaka, Lebade Cabasui, Tachometer, like only this is a proportional vote, our trouble. I trouble our reference signal. Now, nice Bidoma, a Bola, Behao, DC amplifier, amplify of your DC model, be the Elas passing, and our balance with velocity servo mechanism, call it. A servo mechanism about this in the back, change of the Griadima, servo mechanism or don't do that today. Diagram we can see the positioning the servo mechanism. So practical application of the servo mechanism we can control the shift radar. So shift radar control, and then we can see that our DC motors are will rotate the shift rudder, and this DC motor rotation is coupled with the servo tachometer, and then this tachometer the voltage is compared with the reference signal, and then we have to provide with the summons amplifier. So this is the way the position shift rudder position. So when shift rudder rotate, so in this case this also is by the potentiometer. So potentiometer position we also be change, so this potentiometer voltage and the reference voltage are made a comparison and passing through this DC amplifier and try again the DC motor. So this is the positioning the servo mechanism. Now another one is the synchro. Synchros are they are two machines. So inputs are more generator and the output one. So that when the output and inputs are two position are different, in this case it will produce an error signal. The error signal is the amplified into the correction network, and it will turn back to the original position. So this is the way synchro motors are also utilized. Who for the other but let's say position is servo mechanism. Radar DC motor and mounted radar level do it connection, electrical connection, potentiometer and set high. And a potentiometer my triple on the vote on a reference vote on the course, 19 like that, 19 me not quite the vote agova. DC amplifier may be checked when they below IDC motor, pian bomb below, I shall go Mulania or Yao, below be there. Now got a synchro pit, a synchro mass, so not one generate on the Kushi there. I general who are to be the book are the position usually in like era tellare, era udambo, amplify, sense low below, amplify, and low baby or not to correction below be the era balance closer mechanism. Next one with the SCR. SCR being the silicon control rectifier. So SCR got the anode, cathode, and also gate. So when you provide the gate firing signal, the SCR made the conduction. If there is a no gate signal, SCR will not make the conduction. So amount of the conduction depending on the gate firing signal value. So in the left diagram, we see the SCR circuit diagram and the supply diagram. And right one will be the most complete circuit. So in this case, we provide the potentiometer to the SCR gate, so that we adjust in the SCR gate, so that firing in gate voltage will be changed. This firing signal will be changed. So that depending on the gate firing signal, the output voltage will also be changing. So this is the gate firing circuit together with the output load circuit is provided in the diagram. So this is the application of the SCR. So for the SCR, for the electronic control circuit, we utilize the SCR as an electronic switch. Who for the application of SCR, SCR so silicon control rectifier. Now silicon control rectifier anode sheet, cathode sheet to my gate function sheet. Gate about signal voltage below the camera, so I gave a point to Abido, the chassis down the pet and season. Now better bomas SCR function, now the supply function of Popiatare, Yabema SCR Kegoma, Pobio Tilija control of that function sheet. Now SCR Kego position meter and set Abido, not pin or the vote out, pay the boa Pamana the power move or good power choose the outlet so into a firing signal, firing angle, choose the outlet. I don't keep all the firing angle, moody Roma, not two seasons in the Shati John Damodi, and then the chip all the firing angle, moody needed. And I jump like SCIA, no keep firing circuit, not to it output low circuit go, no Yabe Boma for Yana to Yamachete. The next one will be the ADAS. ADAS means that all the input signal, all the digits are waveform can be added, and the output waveform will be provided. So this is the input number. Input numbers can be added, similar to the mathematical addition. So input signal, input digital waveform. So two or more input digital waveforms are combined together, and the output will be produced. So those are the ADAS diagrams. So you see the NOR gate, also the AND gate. Finally, our OR gate. So those OR gates is finally producing the combination function of the input waveform. So this is the full ADAS diagram. Who said you have full ADAS? The full ADAS was let's say mathematical. Ninjania bound the diamond canani bound the logo. Digital signal bound yard. Digital signal bound of the output function. The input signal. Bound the yellow go to be 90. And a bomb piano full and up, get there, do a baba and knock it and get it, now do trouble at it, also wait for us or get out chat. Always the chat, the trouble at the digital way for the logo, social စုကြုံပေါင်းစည်းပြီးတော့အောက်ပို့မှာ waveform ကိုထုတ်ပေးနိုင်တယ်အဲ့ဒါကဘာလဲဆိုရင် full adder ရဲ့ပုံကိုဖော်ပြထားတာဖြစ်တယ် The next one is the full subtractor. Subtractor means that this is for the subtract function. So mathematical subtraction. This we can also provide the digital subtraction. So digital two waveform are subtract and the output result waveform will be produced. So this is the those diagrams are the electrical circuit. So electronic circuit diagram, to the arrangement of the gate and the electronic equipment that's decided to provide the subtractor function. Who said before the amount of full subtractor function? Can I do slow the lobe subtractor is slow you area bio so you are allowed to mathematical subtractor. To the digital waveform level, China below, no Yashi the result go to Beijing the subtract look the local. And the subtract look there, no the digital balance circuit ne, no Tuma Bawine, no say by new, Bonima Popala, to look for Hialo Balaswing, waveform the cool China be Yashi de Yala go to Beijing, Dao Balaswing, full subtractor and circuit. The next one is a counting circuit. So counting circuit means all the electronic bus are counted and the opposite counted number is provided. So this is the counting circuit. So those counting circuits are, this is the basic counter. The counting circuits are decided by cascading the subtractor GK flip-flop. So the input waveform, that waveform will be counting with the how many the waveform, for example, the count gate one produce the input waveform 3 or 4 pass are provided, so then we output waveform produce, or then the next one is the input pass 10 numbers are combined and output wave produce. So this is the ways the counting functions are produced. Input is a serial part, but the appropriate pass combinations are counted and produced by the counted terminals. So those counter include the cascade connection of the subtractor GK flip-flops. Who problem of counting circuit? Counting circuit as input pass color to cool it. That means a pass machine wave and a cool bouncy output waveform. He go to be the counter city. And counter must input my popular than a GK flip-flop to set with Harry. But I'm not counter with that input now full bomb your output. The car took and do the other input say who bomb you output the car took the hello. GK flip-flop, my key the terminator, but as we input pass you, he dread you, bouncy be output mass in the car. She is so took it up today, and as we counter it, fucking today. The next one is the repair counter. Repair counter is count the repair. So how repair numbers are counted by the repair counter. So in diagram, this diagram is a repair counter. Electronic circuit connection for the repair counter. So this repair counter, the input function is counted and the RO1 and RO2. This is the counted functions are produced. Could be for the amount of repair counter today. Input repair counter by let's say to people are the passing machine repair the counter today at all. Any now at our counter circuit poma for the input function, I input function gamma thing, input function machine, I input function the Uma. Edima power in a repair back as you go, count of your function our 2 and a 2 up today. But this is a counting circuit, a repair counter. Repair counter means it can count the repair. So in the circuits, the repair are counted. This repairs are counted by the circuit and there's an output is produced. So this repair counter include the repair or the synchronous counter. They are utilize the flip-flop and the case. They connected within the IC. So within the IC, flip-flop and case are connected and all the repair frequency counted and the output is produced. Who said we probably are repair counter jump today? The repair counter must win to my IC sheet, IC must tema body balance with flip-flop the no counting circuit the body, K the body, no repair frequency or count below output total be up today. The next one is the shift register. Shift register means that it's include the combination of the flip-flop function. The flip-flop function store the information. That information will be the transfer will be shipped from the one flip-flop to another flip-flop depending on the inputs input triggering signal. So triggering signal provided so that in this case the information stored in the one flip-flop is shipped to the another flip-flop up on receiving the triggering signal. So also the set signal by providing the set signal, the information stored in one flip-flop is transferred to the another flip-flop. So this is we call the serial shift register. Who for serial shift register job today? Register the idea flip-flop flip-flop about to a digital information 1 or 0 or any tambo store look at it. Eddie no store look at it tambo to set signal be like that, trigger signal be like that, flip-flop the quality of the who kubia wale, elo kubia mugo, shift register call it. And any shift register saki a board or Poma Pobiana to me. Able data, and your we like able data flip flop. Basically, like your assessing the Billy Gaba, any data, the quality, flip flop the quality, not the cool, Kubiawade, Kubiawaji, that do a register Luyari. So parent counter can be the parent up counter and the parent town counter. So parent up counter we means it's a diagram, provided in the diagram, parent counter Saki. So there will be able function, so input, cloud, and a reset function are connected in the diagram. So that will be all the values are the counted outward. So this is the parent up counter. Who popular no parent up counter job here. Parent up counter input to cloud to reset function to poma popular. Now be like the waveform the tambo the PV and mean that you the counter the parent up counter today. 2 years set when diagram of poma popular to Yamachede. The next one will be the parent counter. So parent counter there will be the input functions is provided, and the input function is that this is for the input once input function. So separate input functions are connected to the parent to the GK flip flop. The output functions are counted and then produced. This is for the parent counter. So this is the input function. One input function is provided to the separate GK flip flop. Parallelly, then based on those are input function, the JK flip-flop with the counting and the output is a produce. So this is the parallel function, parallel counter function. Who problem of parallel counter today and input function the cool there over no. I set way below the JK flip-flop use talk be like it. I talk be like the input function for moody below. No, the flip-flop they are download the function go output the line below set your top of behind it.